I'm going to talk today about round bale storage losses. I'm not going to talk anything about harvest losses or feeding losses. It's just going to be on storage losses. And I'm going to look at it from the perspective of storing your bales outside or with no protection other than what they were baled in, maybe net wrap or string tied bales. So some of the losses that can occur on our bales can occur from sunlight, rain, snow and ice, evaporation, as well as things happening on the soil and ground when it comes in contact with these bales. How would you value this large round bale of hay? This is a 5 by 5.5 large round bale of hay. It's from a field that produces alfalfa and orchard grass. This bale is less than 2 weeks old. So how would you value this round bale of hay? And then how would you value these two round bales of hay? These bales were actually baled in 2019. They came from the same field, about 60 days difference in harvest time from the same baler. And these were both for sale at this producer's place, setting out in their front yard, and I took pictures of them. But again, how would you value each one of these? And I contend there's a significant difference in value, even though they may weigh the same amount. What about these bales here? How would the value of these be? The one on your right is an alfalfa bale that was baled in 2020. It's string tied. The one on your left was baled in 2019 and was fed this past winter. So there was some work done in Florida a few years ago to determine the volume of hay in each foot of diameter of a bale or each 6-inch layer of a 5 by 5 foot large round bale of hay. And what they found based on this targets or circles that you see here is the outer 6 inches of a 5 foot by 5 foot diameter round bale. The volume there was about 33.1% of the bale. The next 6 inches was 26.4%. When you add them two numbers up, that is 59.5% of the bale is in the outer 12 inches of that bale or the outer 2 foot of the diameter. In our area, we use a lot of big round balers that are 5 by 6 bale type balers. While most producers do not make 5 by 6 bales, they usually make a 5 by 5.5 bale or somewhere close to a 66-inch diameter bale. So what I did was took the data from the Florida research and then added that additional 3 inches to the bale to get us at a 5.5. And what I found is in a 5 by 5.5 large round bale of hay that weighs around 1,400 pounds, this would be a bale that's about 12 pounds per cubic foot on bale density. That outer 3 inches or this black layer you see on the outside represents about 17.7% of the bale or 248 pounds. If we add in the next 6 inches, which would be that yellow line, that's 27.2% of the bale or 381 pounds. When we combine them two layers, just the black and just the yellow, and what I've got highlighted in red, that equates to 44.9% of the bale is in that outer 9 inches, or somewhere close to about 629 pounds. And again, bale density will determine some of this, but on this, we're showing a 1,400 pound bale with the bale density somewhere close to 12 pounds per cubic foot. If we add in the next 6-inch layer, that green layer, then by the calculations and the work that Florida did, we are getting 2/3 of the volume of that hay bale, or the weight of that hay bale is in that outer 2.5 foot of that diameter. I think we forget this, and I'm going to show you some information here in a little bit on some of these losses. So them 3 inner rings that we see that are in blue only represent 1/3 of the volume of that bale or 1/3 of the weight of that bale. Well, what about if we stack hay bales with the faces opening on this? I see this quite frequently. This is a picture I took not too long ago, just a few weeks ago. We've got some people that like to stack their hay bales 3 and 4 bales deep and 20 bales across this way. I understand why they're doing it, but we're probably getting much more losses on this than what we think we are when we're leaving a lot of these faces being open on these bales. While it may not be spoilage like we see on the outer diameter, there is a significant decrease in the nutrient values in them bales. So what I did was took a 5-foot wide bale, which would be the width of this bale here. And it doesn't matter the diameter of a bale, but the width on this one is 5 foot. So every 6-inch slice that you would take all the way through this bale would represent 10% of that bale's volume and or weight. So when we're exposing this front face or either side or both sides, again, we're exposing them nutrients to significant losses, and it can significantly impact the value of that bale. Here's a diagram that I put together on that using the same bale with a little bit of color, but the outer 6 inches of this 1,400-pound bale would represent 140 pounds. When you do that on each side of the bale, that 140 pounds on, or 6 inches on each side of the bale comes up to 280 pounds or 20% of that bale. And I would contend we get a significant loss in nutrients on the face of these bales when we store them in this fashion, as some people do. And I understand why they do it, for convenience, for other things, but we are getting a significant loss in nutrient availability and nutrient quality for our animals if we're feeding these to our animals or buying them. To take this a little further, Banta out of Texas A&M wanted to look at the impact of no loss large round bales of hay versus 20% loss on some large round bales of hay. What they did was assumed a cow herd of 25 cows, each cow consuming 26 pounds of dry matter per cow per day, and doing this for 1 week. These bales had a density of about 12 pounds per cubic foot. And when you do the math on that, these 25 cows consuming 26 pounds, that equals 650 pounds of hay needed per day for this herd. And for that entire week, you take that times 7, we need 4,550 pounds of hay needed to feed this herd for 1 week. Banta has a lot more sizes of bales in his research, and then some other columns doing some other things. I just pulled these sizes out because, again, they're more common and up in Northwest Missouri. So I looked at a 5 by 5.5 bale, again, weighing about 1,430 pounds. We need 3.2 of these 1,430 pound bales to feed these 25 cows for 1 week to get to this 4,550 pounds. If we have 20% storage loss based on their numbers, then we get down to 1,144 pound bale of hay. Well, now with that 20% loss, we go from needing 3.2 bales to now 4. And we're going, well, that's not that big a deal. The reality is, if you got 25 cows and you're only feeding hay for 3 or 4 or 5 weeks, this probably is not that big of an issue. But I took these numbers and converted it for a 100 cow operation and went into something that I think is a little more real world in our area. I used the scenario of producers feeding hay, which is down here in this part here, feeding hay from December 1 to April 15th. And again, I'm not considering any drought feeding times. We're not necessarily in a drought in our area. I know other areas are. But when you go from December 1 to April 15th, that is 19 weeks. Excuse my spelling on this. Not very good at spelling. But for them 100 cows for this 19 weeks, you would need 242 large round bales of hay that are 5 by 5.5s. If you have a 20% loss going down to this 1,144 pound bale, now we need 303 bales to get the same feed quality and feed volume, nutrient volume, that we were in this after we take the losses off. When you factor that in, that is 61 additional large round bales that are 5 by 5.5 bales each. When you calculate that on an $80 cost per ton of hay, And what I did was took that and converted it back to $55 a bale for simple math. That equates to an additional $3,355 in feed loss or additional feed cost for this 100 cows in that 19 weeks. And you say, well, our producers get by without that, doing that. And I'm not going to tell you they don't, but if we don't find a way to supplement these losses, how many open females do we get? How many sick cows or poor doing cows do we get? And how many pounds of lighter calf do we get by having this 20% loss? And I contend in some cases we have a much higher loss than 20% on our large round bales of hay than that. And again, remember, I am only talking about storage losses, no feeding losses, and no harvest losses. Again, going back to the work that was done out of Florida, just kind of revisiting it, the outer 3 inches of a 5 by 5.5 bale has about 17.7% of the volume of its hay, or the weight of its hay, which is 248 pounds in just the outer 3 inches. The outer 9 inches, again, is about 45% of the bale. And again, as we showed earlier, the outer 15 inches is 2/3 of the bale. So again, how many inches of spoilage are in each one of these bales? While I did not measure them, I would contend that these bales, this bale here has probably somewhere in that 9-inch range when you factor all of this in all the way back around here. And so I think we're at a higher than 20% loss in nutrient value. Here, probably we're getting close. Again, if you do the math on this and kind of start figuring it, it's probably in that 9-inch range. So again, pretty significant loss in nutrient quality, nutrient value on this hay. And again, this was a bale that I know was fed last winter. I took a picture of it right before a producer was feeding it, and you can see the snow on the ground here. Some other work that BANA did out of Texas A&M looking at large round bales of hay is looking at the bale density. And again, they have a lot more columns and rows on the work they did. I'm going to highlight using bale density on 9 pounds per cubic foot and 12 pounds per cubic foot. They did 9, 10, 11, and 12 pounds per cubic foot on bale density. And then they did bale sizes all the way down to 4.5s, all the way up to a 5 by 6. So again, they did quite a bit of work on this. And I'm just showing some of the highlighted portions that I thought were a little more interesting for our area. When you look at a 5 by 5.5 bale or a 66-inch bale, if it has a 9 pound per cubic foot bale density, that bale weighs 1,070 pounds, even though it is a 5 by 5.5 bale. That same 5 by 5.5 bale, if it has a 12 pounds per cubic foot bale density, that bale goes up to about 1,430 pounds. And just so you know, if you want to do the math, there's 119 cubic feet in volume in a 5 by 5.5 large round hay. So one of the things that Banta also said was that overestimating the bale density on these large round bales of hay is a common mistake. So what they're recommending is people should assume the bale's weight is 10% less than indicated in the above table. So again, I think this shows that, you know, depending on bale density, we can have a significant difference in bale volume, bale weight, not bale volume, just on bale density. And some other things I'll show you here in a little bit is that if we have a lighter bale density, we probably are going to get more spoilage if we're storing these bales outside with no additional protection. How would you value the bale density on these bales? Again, they weren't measured, but these are softer type bales. We can see just by looking at them, they're also string tied bales, but I would contend that these bales are probably in that 9 to 10 range. These next two bales are bales that are much more round, look to be put together a little more dense. Again, don't know what these are exactly, but they're probably in that 11 to 12 pounds per cubic foot and going to hold their shape for a while. As we can see this bale here, even though it has some spoilage here, We're feeding this one in the wintertime and it still held its round shape fairly well. So that tells us that the bale density on this bale was probably fairly significant, at least at harvest time. Excuse me. Some work that was done at the Prairie Agricultural Ministry Institute up in Canada looked at spoilage on these bales and what happens over time. And what they found is as spoilage occurs, the bale flattens, increasing the surface area exposed to the damaging effects of damp soil. And I think we probably think about that on the bottom side, that we get some losses on the bottoms when they do start squatting. But one thing that this picture did for me, opened my eyes up based on their next comment, that flattening also reduces the angle of the top of the bale, which is up here, increasing the bale's exposure to moisture. And when we flatten this bale, when typically this means we're probably getting a bale that is a lighter bale density, they want to squat on us. Guess what? When we get the rain or we get the snow or we get the ice, one is it doesn't shed it near its well. And the other thing is when it's setting up here, probably a higher likelihood that it's going to get absorbed into this bale, further increasing the amount of decrease in nutrient quality on these bales. Again, I thought this was a really neat visual of what can happen with some of these bales if we get a little softer, not as dense of bales in our operation. I think you've seen the picture. If we go back to the $55 per big round bale hay value, which is the way most hay in our country, especially on a large round bale hay side, is priced. It's priced on a per bale basis. If this bale up here in the top center is worth $55, if that's what we put a value on it, and I can tell you the two bales here on the left, the two bales on the right here are both supposed, or all four are supposed to be 5 by 5.5 bales. Are they all still valued at $55 a bale? A lot of the people selling want to tell you that. I think when you're trying to purchase it, you probably want to back off on that number and try to get more of the hay that's something like this, or maybe even something like this. Obviously, this bale here is a lot smaller, and so there's just some different challenges with it. But again, we need to be thinking about this when we are working with our producers or on our own trying to value these large round bales of hay. There's some work that people are doing in our area that I found kind of interesting. They're starting to use these black sleeves on dry hay. Some people are also taking their inline tube wrappers they normally use for baleage, and they're wrapping their dry bales with black plastic. What has been found is the black plastic seems to work much better on the dry hay than the white. White seems to be that we get some condensation in there and we get a little bit of spoilage or mold on that outside. So most people that I know that are wrapping dry hay are using black plastic, and I think getting along fairly well with it.